So imagine that you've constructed a list, and this list is the list of every single prime number that there is. You've gotten to the end of the list, you've listed them all, your list is 2, 3. You think the entirety of all the prime numbers is 2 and 3. Prime numbers, of course, are all about factors and multiples. Primes specifically are defined as any of the positive integers with exactly 2 factors. The numbers that aren't prime, the composite numbers, we construct out of the prime numbers. So for example, we could construct a composite number by multiplying 2 times 3 right now and getting 6. The way numbers work though, if we take a multiple of a bunch of numbers and add 1 to that number, the new number we've generated can't be a multiple of the numbers we used to generate that first number, in this case 6. But for us that causes a problem. This new number 7 can't be a multiple of either 2 or 3, and the only way that's possible is if that number itself is prime, or if there's another prime number that is actually a factor of that number. In this case, obviously 7 itself is prime, and that shows for sure our original list must have been incomplete. For an example of the second kind, imagine that our list of all the possible primes was 3 and 5. We figured 3 and 5 were all the primes that there are. 3 times 5 is 15, and 15 plus 1 is 16, and although this time 16 itself is not prime, it is a multiple of a prime that's not on our list. Specifically, it's a multiple of 2. But it's still the case that our list could not have been complete. And indeed, for any finite number of primes, this method shows us that list will always be incomplete, meaning the list of prime numbers must in fact be infinite.